Thank you all for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes including Q&A. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Quick word on a code of conduct. We are all here to learn, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. I would now like to welcome David and Vivek, our speaker for today's session. David is the founder of ARGOS, a cloud security SaaS product. He has held the Microsoft MVP award for many years, including the prestigious MVP for Azure. A regular speaker at international conferences, meetups, and user group. He combines his interest to travel the world with his passion to share IT stories with the community. Our next speaker, Vivek, is a tech enthusiast and an open source contributor with around 15 years of experience in the software industry. He works at Microsoft as a senior cloud advocate. But for now, I will hand over to both of you to begin the session. Over to you.
Hey Rashmita, thank you very much for the introduction. Hello, David. Welcome
Hi,
to
Vivek.
Azure Happy Hour. And just a context, if you don't know what Azure Happy Hour is every Friday we meet and we discuss about Azure integrations with different open source tools and Azure as a whole. And we have amazing guests joining us every week, or it's me who is driving a couple of sessions as well. So, welcome to the show again. I know that it's pretty late in Melbourne. It's like almost like what 10
It's
9:30
it's
p.m.
9:30 at the moment. Yes,
Uh,
9:30 p.m. Yeah,
somehow most of my shows, people are either joining in 3 a.m. or 6 p.m. 6 a.m. Or the 9:30. It's great to see that global presence in my show, which is good. And just for audience, just to introduce David. He's been a he's been a developer. He's been a principal architect, DevOps consultant, a founder, and also Microsoft MVP, right? And that's amazing. That's amazing background. It's nice to have you in my show and have a chat with you as well. And thanks for coming in again. Um, to start with, David, so I just wanted to understand uh, what does Argos do? What does your product Argos do? And what is what's the background behind building such a SaaS product?
sure. Well, first of all, thanks for having me. So Argos is a cloud security product. Argos detects and investigates cloud security issues in your cloud environment and can then fix them. So we have auto remediation for everything we find in your cloud environment. It's full SaaS, so we built a 100% SaaS in Azure. And yeah, that's what Argos does. We find issues, we find security issues, and fix them for you.
So I want to understand when you talk about security, right? So just for the audience and for myself, what's your perspective of cloud security, and what is the state of today in industry, right? What is the state of what do you feel? How industry is taking this, and where do we stand? Are we fully secure, or people are very aware of how to get secured themselves, or how is it? How does industry is as well?
Yeah, good question. So I think look, I've been doing cloud since 2009. So very, very early on. And data centers and everything in between, hybrid, full cloud, full on-prem. And I think overall, as an industry, we are still getting the basics wrong. Like, we haven't really moved on from what we did wrong 20 years ago. We're still doing wrong today. It's just that we're doing it wrong at a different scale. And this is not to point fingers at anybody. Cloud just makes things a lot more complicated, and the impact of getting something wrong is a lot bigger than what it was on premises. Log4j, yeah, our Java vulnerability that we learned about last week and beginning of the week, and now today again, is a good reminder that also on premises in your data center, you got something wrong, and really somebody had to actively target you most of the times for that misconfiguration to have an impact. In the cloud, everybody knows your IP address. Like, everybody knows Microsoft's public IP range, so everybody is scanning it all the time. And with something like Log4j, there's internet scanners out there. If you put something onto the internet, it will get tested by something in a matter of seconds. So the scale of misconfigurations, the impact is a lot bigger nowadays. And what does cloud security really mean to me is, and why did I build a cloud security posture management product, a CSPM, where we already have dozens of CSPMs out there? I believe that we, and our customers tend to agree, that as an industry, again, we kind of thought that CSPMs were doing something different to what they're actually doing. So we have great CSPMs out there at the moment, including Defender for Cloud, formerly known as Security Center, that look at your environment and map everything to NIST, HIPAA, CIS, Azure Security Benchmark, etc., etc. But what they tend to not necessarily do is tell you what of these misconfigurations is actually a security issue and what is just, in quotes, an operational best practice violation, where you could have a public IP on something, but who cares if the network security group on that virtual machine is blocking everything? CSPMs will tell you, you have a public IP on a virtual machine, you shouldn't have that, get rid of that. Yeah, but in the grand scheme of my environment, I should probably be notified about the virtual machines that have a network security group that is actively exposing a port that people can actually test, like 3389 RDP or SSH, and start brute forcing that. That's what a cloud security product, in my opinion, should really focus on. If you need to know how compliant you are, CSPMs, funnily enough, are very good at showing you compliance, but in my opinion, not necessarily great at showing you the security posture of your environment. And that's the state where we're now seeing a few more startups popping up that are almost creating a new iteration of CSPMs that come out of the learnings of the first generation of CSPMs, rather.
Yeah. So you did mention about the the posture management, and just for the audience, to understand it in a better way, like, what is that posture management? When you talk about like cloud security posture management, what does really it do, right? Can you just brief about that?
Yeah. So historically, a CSPM would go and scan your environment, scan your infrastructure. So everything at the API level, the cloud API level, make a bunch of API calls and compare whatever the configuration of those services and resources is to a benchmark, either the Azure security benchmark, HIPAA, NIST, CIS, GDPR, etc., etc., and then tell you are violating control X, Y, and Z. That's what a CSPM roughly does. The way Argos does it is we actually not necessarily map, and then they tell you how compliant you are towards those benchmarks. Problem with that approach, in my opinion, is that you get a false sense of compliance, because these compliance frameworks really only look at a subset of your overall compliance audit, really, in the end, and say, well, the API level, the configuration, that's kind of compliant to PCI, but PCI itself is a lot bigger than that. Plus, it's also that compliance is very interesting to security teams, to GRC, so governance, risk, and compliance teams. But what the cloud teams, the infrastructure teams, DevSecOps teams, what they are more interested in is, okay, what are the actual security issues and what do you want me to do about them? A infrastructure team is probably only secondary interested in how compliant you are and more interested in how secure you are.
Got it. Got it. So, in a nutshell, so basically, I'm trying to understand this in a better way. That if there is a security issue found and it gets updated, say for example, I'm a healthcare in industry and I have a HIPAA compliant systems, and there is HIPAA compliance. They add something new into the HIPAA channel. The CS, the posture management system picks it up, and whenever that you're running your tool, it basically interacts with this new compliant thing which has come in, and it tells me that it is whether this is my system is not compliant to the new one or not.
That's the idea, yes.
Okay, that's interesting. So now I'm pretty getting interesting here is because how do you build this system? How is this system built from an architecture perspective?
Yeah.
And not just that, I'm pretty interested in knowing about your journey as a startup. How did you think about building it right at the first time? I read your description
Mm.
when you sent me that description, that you made sure that you wanted to build it right when you build it right at the first time when you build it right. So and it's interesting. I want to hear that story from you.
Yeah, absolutely. Look, as I mentioned, I've been a consultant for over a decade. I've seen many organizations from very small to uber large, as in really big, and I've worked with many startups as well. And often when the consultant came in, when I came in, when my team came in to those startups, the first thing that had to be done was, we really need to refactor everything, because you just deployed your application that is now running a couple of dozen customers on a single virtual machine under somebody's desk. And there's no security, there's no scaling, no resilience, there's no automation, none of that. And now you need to spend money and effort again to do that. And that was often the case with teams not necessarily super familiar with cloud. And often there's the argument that, yeah, of course you do it that way, because that's your MVP. Yeah, that's your minimum viable product. You don't want to go and design it to scale into infinity, because your startup might be dead in a month or in a year. So if you're spending all this time and effort coming up with this great scaling environment or architecture, you might be doing it for nothing, because you're not around in a year. So, and that's very true if we're talking about data center. Yeah, in a data center, you don't want to go and buy all the hardware so you can scale for hundreds of customers and spend all that money if you don't know if you're going to be around for longer than a couple of weeks or months. In the cloud, however, it's very, very different, because we can now actually use services that make it very easy for us and quickly make it easy for us to deploy an application onto those services and then just stay there. And that's not a virtual machine, and we can just stay on those services. And those services enable us to scale and be resilient, go multi-region very easily eventually. And it's not more effort, it's actually less effort to go with those services. And I can show an architecture diagram later on with those services than going to a virtual machine. I can tell you, we have not patched any operating system in 16 months. Why? Because we don't even know what operating systems, or actually we do, but we don't interact with any operating system. We're not deploying to an operating system. We're deploying to an API, to a service, and that's it. We're actually having less to do, fewer things to do, than if we had gone and just deployed to a virtual machine. So we had that approach. Yes, start small, but use services that can very easily, if we're successful, which as a startup you never really know in the beginning, but if we're successful, we can scale very easily, pretty much with the click of a button.
Yeah, I mean that's the whole point. So, I've while I was in my previous roles, I was interacting with startups. This used to be the common issue with them. Like, yeah, we are scaling. What to do next? Because my systems are failing because we are scaling, and that's the idea behind, like, how do we build a system which is also small, and then while we start, but also it's scalable as the request grows, as the customers grow as well. So that's a interesting thought, and I mean, I just want to understand how did you do it. And
Yeah,
by the way, so
yeah,
I want to understand your architecture as well. If you can share that
yeah,
architecture to the audience and to me, I'll have more questions to you, so that we can discuss more on that.
yeah. Look, so the in a sentence, in a nutshell, it was really, I wanted to make sure that scaling for us is not a technical issue, but a sales issue. Yeah, if sales was successful, if the application was successful, I wanted to make sure that it was just gonna happen. It was just going to be scaling whenever it had to scale. And the way we did it was actually very simple. Our application is a very well-known pattern. It's a 3-tier application. You can see up here at 12 o'clock, we have our front end. It's an Angular website. We have our app tier in the middle, and we have our database here at 7 o'clock. So it's a 3-tier application, something we've deployed for decades. Very, very common pattern. No magic in here, really. So back in the days, this one was an IaaS hosted service, probably on Windows, or Apache on web server on Linux or something. And you had to go and worry about how to maintain that web server. Now we just deploy our Angular web app to the storage account. It's a one-liner that we deploy. We copy those files, those static files, to the website. That's it. We have behind the CDN, but the CDN is really just to accelerate content transfer, content delivery globally. The app itself, it's actually written in or developed in .NET, in .NET Core. We deployed onto Linux Azure Functions. So it's a function app. Again, no virtual machine, nothing to patch, nothing to make sure we have more than one off. It just been taken care of by the infrastructure, and our database is Cosmos DB. Fully managed service, All of these are fully managed, nothing we have to worry about. And we can go into why each of these in the next couple of slides if you want. But really, the main idea was, and I have this here, our golden rules really. Number one was all in on Azure. Yeah, pick a cloud. That's kind of what I tell everybody. Pick a cloud and go all in. And when and if you really, really, really need to go to a different cloud, do it later on once you are doing one cloud well. And then maybe go to another cloud. That's just from experience, but all in on Azure. Full vendor lock-in. I don't believe that's a bad thing. I believe vendor lock-in can be a really, really good thing. We never had an issue locking ourselves into VMware in data centers or Hyper-V, but suddenly in the cloud, that seems to be a massive issue to people. Not sure why. And PaaS, if possible. We absolutely did not want to manage any virtual machines. Why? Because we are not in the business of selling virtual machines. We are in the business of selling a cloud security product. And patching a Windows or a Linux VM does not make us money. So PaaS, everything that we don't need to worry about, we push it to Microsoft because they're probably much better at doing it than us. We had a couple of other rules. Obviously, as a cloud security product, very strict focus on security. In the cloud, you get a lot of stuff for free, as it turns out. And I can mention that, and that kind of influenced our service selection as well. If we had to go third party with certain integrations, we wanted to make sure they had startup tiers, free tiers, very low or very high discounts. Buy over build kind of goes into PaaS as well. And if there's already a product out there, again, they're probably better at running that functionality than if we were to build it ourselves. And automate everything. All of this architecture is fully automated. There's no clicking around in the console anywhere. There's no let's just click this button to make something work. It's fully automated end to end. And those are really our main rules on how we wanted to build Argos and how we then ended up building it.
And that's an interesting one. So you have the front end completely built on the Angular and just on the storage, and
Yes.
you have Azure CDN which is there, and then functions to run a couple of things, and then Cosmos DB and other things which you are using with third-party integrations. So all this is sitting at as one environment. Do you have a couple of more environments for this to do CI/CD and other things, right? I mean, that's one more part of it.
Yeah, so we do a lot of local development. The really nice thing with all of this here is that our developers can actually develop all of this and run this locally as well. So every developer can have, Cosmos DB has a local emulator that runs cross-platform very, very nicely. Functions, they just run in VS Code or Visual Studio. Very easily, you just run the app and everything connects back to the Cosmos DB local emulator. And Angular also just runs on your local laptop. We can run all of this isolated on anybody's laptop. We do have a dev environment, or more a test environment, which is very, very down-specced that we can deploy on demand. And then really we have the prod with all the integrations.
So can you just go through the each section
Sure.
and talk about a little bit more of challenges you faced,
Yeah.
and how have you set up the functions, in fact. So
Yeah.
it's pretty interesting. We will come to your product. We
Yeah.
will see a demo of your product so that we can relate all those things to this. How have you developed that specific thing?
Yeah.
But I want to understand how you developed your functions. What was your strategy behind the functions? What different kind of triggers you have used, and also obviously the front end development and challenges you have faced there.
Yeah, absolutely. So yeah, let me just quickly talk about the front end, because that's kind of the boring part. um, and mainly because it's supposed to be boring. All of this is supposed to be very boring. The product is supposed to be really, really interesting. The more boring your infrastructure can be, really the better, the more resilient, the more secure you can actually build it. Um, I'm always frightened when I see architecture diagrams that just look like a spider web of dozens of resources talking to each other, and you just think that there's too much stuff happening, that just chaos waiting to happen. So front end, very, very boring. It's an Angular web app running on Azure Storage Account static website, behind the CDN, as I mentioned. Why? Because it's super cheap. It really is super cheap. We pay $24 a month. That's Aussie dollars. So that's probably 15 US dollars a month for our website. That's nothing. That means we don't have to maintain our virtual machine or a virtual machine. We don't have to configure IIS or any other web server. We don't have to patch any of this. High availability out of the box. If I wanted to have globally redundant storage, we just make a change to our infrastructure as code here, which is actually Pulumi. So I see Mithun here asking a question. We're using Pulumi for our infrastructure deployment. Mainly, why is probably the follow-up question. Why are we using Pulumi? Because Pulumi enables us to also configure our third-party integrations. So in our infrastructure as code, we can configure everything on Azure and everything on our third-party integrations as well. So that's really very powerful that we can do all of that in one code base, basically. So this is the TypeScript infrastructure as code here. How do you ensure tenant level isolation with above architecture? And some customers would be very keen on that. Yeah, look, we do it at the data level, where our application makes sure that if your request comes with a essentially customer ID, all your requests come with a customer ID, and that is being authenticated and verified by our application, so that the only data that you can see is your own data. There's no way for you to see other customers' data. You're linked to your data, your own tenant essentially, and there's no way that you can see any other tenant's data. So it's all in the app, really. So that's the front end, basically. Very boring, as I said, and I dare you to find a virtual machine that costs $24 a month and gives you high availability out of the box for free, and where you don't have to patch anything. Also, make sure you understand that's all being taken care of for us. If we ran a virtual machine, that $24 would be higher because of the virtual machine, but also we have to pay money, essentially our cost, our effort, to patch, configure, etc. So the actual running cost of a VM is usually much, 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 much higher. So the app, the functions, the really, really interesting bit. We started on the Linux dynamic consumption plan because it's free for quite a while. consumption, you get 500,000 requests a month for free, I think, 500,000, and quite a bit of other memory for free, which meant great. We don't have to pay for anything. Amazing. Plus, it automatically scales, which is, again, great. Nothing for us to worry about. Functions as a service means no need to patch anything except our code. And I can only repeat myself, you don't want to worry about anything that's not your code. So if there's an offering by any cloud provider, Microsoft here, that enables you to not worry about patching operating systems or anything that doesn't make you money, push it to Microsoft. They can deal with it. Pay them a bit more, but it's not going to be as expensive as if you had to worry about it. Down here we have our Pulumi code again for the app service plan, and you can see that we already assumed that eventually we will have to move off the dynamic consumption plan. We already had the premium plan commented out in our code. We knew eventually we would have to move off and actually start paying money. So we already put it in here, but just keep that in mind. Over here on the right, the actual function app, the configuration, you can see we enforce HTTPS only, because if we didn't, our own application ARGOS would complain about ARGOS's configuration. So we use ARGOS to monitor ARGOS as well. Just like Azure DevOps is used to build and deploy Azure DevOps. So we use ARGOS to monitor ARGOS's security. We have all this site config here, and the identity, again, security related. We use Azure Functions Managed Identity to talk to all the other services on Azure that we need to talk to. We don't have any credentials hard-coded anywhere, nothing that we need to manage or worry about. We just use Managed Identity and let the services take care of the rest. So this is the functions design that we initially came up with. To just give you an idea, this is just our application. This is the core application, not the front end. So the front end is all HTTP triggered. Front end, you click on a button in our dashboard, and that calls an API that's HTTP triggered, and it does something and responds back. This here is our scanner, basically. This here is every minute, this timer triggered function would execute, put messages onto a storage queue, and put it onto a storage queue. And then there are plenty of other functions that would know what to do if there was a message on the storage queue. This was great initially, where it was really just every minute or so, we got a new message and we scanned. Problem with that was that we eventually ended up changing a bit of that scanner and wanted something else to happen here after these were done. We wanted, after these queue-triggered functions were completed, we wanted something else to happen. And that suddenly becomes difficult if we continue to use this here. We could have put state into another storage queue or into a blob storage or into a database and had then other functions be triggered by that event. We could have built that, but remember, buy over build. We didn't. We ended up using durable functions. Because with durable functions, we can actually run these asynchronous events. We can actually run these activities that then go and notify another orchestration or another activity on our function app. And that's what we ended up building. We essentially have a timer-triggered orchestration here. That's our main orchestrator. But then asynchronously calls all of these activities, and they automatically fan out. They fan out, do their stuff, do whatever they need to do, write stuff to a database. And once they're done, they fan in again and they notify the main orchestration, hey, I'm done. You need to do some other things now. This one now actually calls other activities. So essentially, this just continues for a couple of times. But we don't
So,
have to build any of that state.
so I have a question here. So you are using time and trigger because you want to run it every minute
Mm,
and scan the different things which is required from the vulnerability perspective. So
yes.
you are scanning through everything, and there are a couple of questions there basically.
Yeah.
One is, how does it affect my application performance? Does it have an effect on the performance of my application, because you're running every minute to see if there is any open-ended issues with my
Mm.
infrastructure, my application and everything. I'm thinking the security perspective is both the ways, like infrastructure, hardware, and then also you're looking at the application side of it both. So
So
how does it work? And the second question is, uh, just for the audience, if you can tell us what is durable functions is, what does it do? Just gives more perspective for the audience as well, because some might be very new to
mm,
durable functions, and just give them a kind of an introduction to it. That will be helpful.
yeah, absolutely. So your first question, what impact does it have to me as the customer? Not a lot. Let's put it that way. We don't look actually at the application. So we stop at the cloud API layer. We don't look into your operating system. We don't look into your database. We don't look into your storage account. We just ask Azure, please tell us what the VM's configuration is. We don't then look into the virtual machine. So we don't have any impact onto any metrics of your virtual machines. Um, there might be some might be some API quota that some organizations might be concerned about if we were too aggressive with our timer here. But so far we have customers with a couple of hundred Azure subscriptions, and we've not hit any limits. And we're very confident that even if we were to get to customers with thousands of subscriptions, and they're quite rare, we would still be able to not we would still be able to work around any of these limitations if we were to hit them. So our API requests are actually um, fairly non-intrusive to your API quotas. Second question, what are durable functions? Durable functions allow you to write these asynchronous events, basically. So this timer triggered function could, let's say, you want this function here to do something and then execute another function. But you want this function here, this timer triggered function, to wait for this function here in the middle to complete. Without durable functions, that's difficult. It's doable, but it's very, very difficult to develop that because you have to develop like a loop. You have to check from here. You have to check the status of this. You have to do a lot of error handling. What if this one here fails, but this one doesn't? So how do you pick things back up? Durable functions allow us to say this one here on the left calls the one in the middle. This one on the left waits for the one in the middle. The one in the middle is completed, calls back to the one on the left and says, hey, I'm done. This is the output. And then the one on the left continues again. And then it can go and call other activities, other functions, essentially. And there's many, many different patterns that you can follow. The documentation on this is actually rather good, with some really good patterns, development patterns on how to build this. This is a fairly simple one. Again, we wanted to be boring in our infrastructure because the application itself is quite complicated. And wanted to make sure that the infrastructure itself is quite straightforward. So we have this quite easy timer-triggered orchestration that executes every couple of minutes, calls our scanning activities, and they notify the main orchestration again. Hey, we're done. This is our output. This is what we want you to do.
There is a question in the chat. There are two questions basically. One on, so this is regarding your Azure functions, the consumption plan, and eventually you have to move to the premium plan. So, but there is a question, while you are at the consumption plan, is there a cold start issues?
There are cold start issues on the consumption plan because they go to sleep after a while. However, because ARGOS actually runs pretty much continuously, we excuse me, we never actually ended up having that issue. We executed a new function. Our timer executed the function before it went to sleep. And yeah, now that we're on the premium plan, we don't go to sleep anymore.
Even if you want to sleep, you can't.
Yeah.
So the other question is, since you're saying, it's going to connect with the customer subscription, how is that from a permission perspective? What kind of roles you have to run this thing? Yeah.
Yes. Gonna bag on some other products now. Unlike other products, we don't ask you for a owner or contributor permission. It's correct. We only need read access. So you can scope us to whatever you want us to scope, whatever you want to scope us to. You can give us read access to a resource group or a subscription or many other subscriptions. We're about to support management groups. But yeah, read access is all you need. If all you want is the actual misconfigurations, the security issues on the dashboard, if you wanted remediation as well, so we support remediation out of the box, then we need more than read access. But so we can make the actual changes on your Azure subscription. But if all you want is the scan, then read access is all we need.
So that's it from the questions from the audience, though.
Right.
Yeah, you can talk about the scale part of it.
Yeah.
How are you scaling now? This was all about building the startup right, building the tech right, and now it's like, how do you scale?
Yeah. So we chose Azure functions because they automatically scale. It's easy to deploy them into a dedicated app service plan, into a premium plan. And before we used durable functions, we also had no worries, no fear of missing anything in our application, because we used queues, and queues use storage accounts underneath, and they have, I think, 11 nines durability now, an obscene amount of nines of durability. So even if our application went down for a minute or so, which it doesn't, fingers crossed, touch wood, we wouldn't miss any message. However, at some point we saw this in our metrics. And if you know anything about dynamic consumption plan, you will know why I drew this line at 1.5 gigabytes of memory consumption. Because the dynamic consumption plan is limited to 1.5 gigabytes of memory. And as you can see, we eventually started dipping over these 1.5, and then you dip long enough over the 1.5 and then crash, and the application stops and comes back up. We probably at this point, that was in February this year, had a bit of a memory issue, but really overall, the issue was a good one. We added a lot more features to the application. The application just grew. It is a .NET application, so it does want a bit, it is a bit hungrier in some cases. Our daily active users increased. We got more customers. Today, we have 113 functions in this one function app. I recommend to not put 113 functions into a single function app, because you will end up having some performance issues, and we're working on splitting that up now into multiple function apps. But overall, it was a good problem to have. Yeah, we added more features. People like the application, our product. They used it more. We scanned more subscriptions and customer environments. It was good. So at this point, our application was really definitely memory constrained on the consumption plan. So as you remember, going back to that first slide on the functions, we already had the premium plan in our code. So what we did was we commented that out. So we uncommented that line. We put the Elastic Premium plan in here, committed the code, and 10 minutes later, we were running on a premium plan. So because Pulumi and infrastructure as code and CI/CD, it was very, very easy for us to go from the free tier to the premium plan. And that's kind of the app tier. So if you want, we can talk about Cosmos DB as well, because that's very exciting. So can maybe quickly have a chat about that if you want.
Yeah, sure. Go ahead.
Yeah. So as I mentioned, Cosmos DB is our backend. Again, why? Because it does come with a free tier. Amazing. You can use it. You can use Cosmos DB in as free tier once in your tenant, I believe. So you need to make sure that you pick the right Cosmos DB that you want to come with the free tier. Initially, we paid around $600 a month for Cosmos DB. Cosmos DB, if you don't optimize it, will be expensive. And I'm going to get into that in a second. Why Cosmos DB? Because it's so easy to use with functions. It's stupidly easy. Input and output bindings for functions, the best feature ever. You can talk about any other cloud and their functions and how good they are. Nothing compares to input and output bindings. The amount of work saved by using output bindings and input bindings on functions is just massive. We use SendGrid to send emails, and it's literally, I think, 5 lines of code to send emails. Because we don't have to integrate into SendGrid at all. We just tell the function, whatever the return object is, push it over to SendGrid. Amazing. Same with Cosmos DB. Whatever the return object is, put it into this collection. Done. Really, really easy. Plus, no patching. You get HA for free. There's 4 replicas of data in one region. Very easy. Auto-scaling based on demand. So we initially didn't auto-scale our Cosmos DB account. We actually went the other way. We used fixed request units. I'm not necessarily going to go into what a request unit is now in this session, but we used fixed request units, essentially fixed compute for our database container. And now we're using auto-scaling on a few of our collections. We currently at the moment have around 44 million requests per month. That's pretty much 100% growth over 2 months. And we are storing around 1.4 now, probably because those slides are about a month old, probably closer to 1.7, 1.8 million documents in our database. You can see we have 2 Cosmos DB accounts now. One, the big one here in Australia, the smaller one at the moment in Europe. For data residency reasons, we deploy into the European Union. We're very shortly going to also deploy into the US a database account. So we deploy pretty much on demand, and because it's all in code, it takes us a couple of minutes to deploy a new database and have our customers select the right database for them.
Got it. So, there are a couple of questions
Oh
though.
yeah.
So, why there is no API management gateway? Like,
Oh yeah.
yeah,
Yes.
what is the reason behind there is no API management gateway?
There actually is. So we do have an API management gateway. The it just not on the architecture diagram. It would just blow that architecture diagram up. We use it to expose our APIs, some of our APIs, a subset of our APIs to customers. And yes, in that case, we do use rate limiting for customers on different plans. For example, the JOT validation happens via the app at the moment, not via API management gateway. So yeah, we do use some of the API management gateway functionalities, not all of them, but especially we use the rate limiting already. Yeah.
Yeah, there are a couple of more questions coming in.
Yeah,
So
sure,
let's
absolutely.
give it. Yeah, so this is so basically on the multi-tenancy. If you all connect to customer ID, separate databases, how do you deal with
Yeah.
multi-tenancy? Yeah.
Yeah. So we use customer ID essentially. However, there's some other tokens that we have internally to ensure that you can't just go and guess a customer ID and then fake a request. So there's a couple of other things that on the record I'm not necessarily going to go into. So you can't go and pen test our application. No, it has been tested. It is safe for multi-tenancy. We have we have one database, a multi-tenanted database in this case. So our design is fully multi-tenant. We don't deploy separate databases. That would just not be commercially viable.
There is an interesting question, by the way. This is more from why not Kubernetes deployment?
Mm.
Is it specifically because of the cost? I can take this. It's yes, because if you see this architecture and other things, and also the scale. But yeah, I will let you answer as well.
Yeah, Kubernetes would not give us any benefit here. Nothing. Not a single benefit that anybody can think of. If you can think of a benefit, let me know, and we'll go right away to Kubernetes. There seriously isn't one. I've helped many organizations deploy Kubernetes clusters, and often for them it made sense, but they usually then also have to go and hire a full team of Kubernetes experts that just look after the clusters. Yes, we have cloud apps now, managed, or where you can use Dapper, etc., that we haven't looked into. But I know there's massive hype around containerization, but there's also 10 different ways of running containers on Azure without looking at Kubernetes. We don't need anything that Kubernetes gives you in our application. That's kind of the very honest, transparent answer. There's no reason to do it.
Yeah, and you don't have much microservices as well. So to even go and build
Yeah,
with the
I
Kubernetes. And also you don't need a much of hardware, because most of the things are being interacted with APIs, and data is coming into the storage, and that's it. So you're
correct.
working through that. So that's a good one. And before let I mean I would ask audience to keep posting their questions in the chat. While they do it, I'm pretty much interested in seeing your product.
Hmm,
If you can spend some 10 minutes or 15 minutes time to
sure,
just show us the product, what does it do, and how we can connect all your architecture, all the discussions to your product.
sure. Let me just move you over here and share this one. All right. So this is the dashboard. As I mentioned, it's full SaaS, and the main thing that we want to see, or that we want our customers to see, is really this table here. This is how we focus them on the important issues in their environment. And let's just, because we're talking Azure tonight, let's just filter by the Azure detections that we have. And there's several detections that we know of. CSPMs, all CSPMs are going to show you this left column here of total detections. What Argos then does is we investigate, and that's all the whole scan basically. So we reach out to your environment once, get your configuration, and we come up with these detections. And then there's a lot of logic that runs on top of that to come up with which of these are actually exploitable, which of these are exposed to the internet. Very, very timely at the moment. Um, some of our customers are actually telling us, and I did not expect that. We did not go to anybody and run a marketing campaign on use Argos to fix log4j, because that's not what we do. We don't fix any log4j or anything. We don't even know if you run Java on your virtual machines or not. Not what we know. However, some of our customers told us, but they used Argos to prioritize which VMs to look at first. So they used Argos to know, all right, out of my 1,000 publicly exposed network security groups, actually only 3 were exposed to the internet because they actually had a virtual machine attached to it that had a public IP that had RDP open. So we can click on this 3 here to see these 3 security groups that are exposed to the internet. We can select one of them, and we then get a bit of information about what this detection actually means. We're all very technical, I assume, so ensure RDP access is restricted from the internet. That's a good thing to do either way, but often that can also mean it's just a network security group that somebody deployed. And a CSPM will tell you there's an NSG that has RDP open to the internet, but that NSG is not attached to anything. So why do you care? That's the compliance operational best practice violation that I mentioned. This NSG here, we can find it down here. That's attached to this network interface, attached to this virtual machine. That virtual machine has this public IP on this network interface. It's in this subnet, in this virtual network. And in the subnet, there's all these other network interfaces as well. So we can see up here, this misconfiguration, according to the MITRE attack framework, that's the only framework we do actually use, can be used in these ways here. So we map each detection to MITRE attack to educate and explain how somebody could actually use this misconfiguration, how threat actors can move through your environment. And that means that somebody getting onto this virtual machine, we all know network security groups, what do they allow by default? Inter-virtual network traffic. So you get onto this virtual machine because it's got RDP open to the internet. You pretty much have network access to all these other virtual machines as well by default. Why? Because nobody changes that. I have not come across anybody who actually changes. If you look at the network security group configuration here, who changes the default security rules, allow inbound traffic from all VMs in VNet. I have never seen anybody change that. What people do is they deploy into a different VNet, but then they peer the VNets, and then suddenly you can talk again. So we show you that configuration here, and if you wanted to, you could click on that link here and then get to the actual resource in the console. We can see, yep, it has RDP open, any, and if you wanted to, if you gave us more than read access, we could now click remediate. Remediation triggered successfully. We go over here again. Let's just wait for it to actually do it. Sometimes takes a few seconds, but once it's done, that network security group does not have that rule anymore, and it's gone. So that's kind of what ARGOS does. We have a few other things in here, like our resource map, where we show you resources mapped to where they are in your environment. That's sometimes a bit of a surprise to some customers where they actually have stuff. Especially here in Australia, I assume it's similar in India, where you have legislation that says data needs to stay inside of the country, and customers are vehement to go and we only have stuff in Australia, and they hook ARGOS up, and then suddenly they have all these dots in other countries, and they go, "What is that? Who deployed stuff in I don't know, in Dublin?" And you go, yeah, let's see, what is that? And you then see, right, somebody deployed a Cosmos DB here in that environment. And this one is actually interesting because that's the oh my god, not the oh my god, that's the Chaos DB vulnerability that Wiz detected. But good thing, at least it's in the subnet, so that Cosmos DB is attached to a virtual network. It's not exposed to the internet, luckily. So kind of all right, but we should probably fix that and rotate the keys. On top of that, we connect into your Sentinel, so we can send all these detections into Sentinel. So you can have everything inside of Log Analytics and your SIEM to correlate anything we find to other events in your environment. We send detections into Slack or Teams. And yeah, all of that, every single thing that you saw, it's a function somewhere. It's somewhere it's a function that executes queries against Cosmos DB to fill out all of this here. And you see it's fast, right? It's, if I don't, now that I refresh, but yeah, see, that's the data. It's there. It is really fast. And I do like the fact that we don't necessarily have to worry about any performance issues because it automatically scales.
This is perfect. So the front end is, again, it's completely on the storage, and again it's on the CDN, so which is again helping you to build that cache, and it's help
Yeah.
you in running it faster as well. So there are couple of questions as well. So there is a related questions to the previous line, like how do you scale front end?
Yeah, we don't have to worry about that because it's behind the CDN, so the content gets delivered from the CDN because most of the time somebody else has already filled the cache, so it comes from the CDN. Scaling, it's on storage account, so nothing for us to really worry about. requests are very, very quick on storage. So Microsoft takes care of scaling.
The other
Sticky
question from sticky sessions.
Depends on what's meant by sticky sessions in this context.
Yeah. So for example, a customer is looking into the dashboard and he has logged in and he has a session there. And how does that, how do you manage that session for him? Basically, if he is looking into something and
Right.
maybe something happens at the back end and to your system, it should not be a problem because it's all functions
Yeah.
again. No.
So
So yeah.
the session management, so our identity provider is Auth0. So we use Auth0 for identity federation, essentially. So you can log in with Azure Active Directory, which means we support single sign-on out of the box. You don't pay for single sign-on. Yeah, many vendors make you pay for single sign-on for whatever weird reason. No reason to do that. You all have MFA enabled on your Active Directory, right? So when you log into ARGOS, you're being prompted with MFA out of the box for free. You don't pay for that. So that's how we. So Auth0 gives us a token. We use that token to manage your session on the front end. And on the back end, I mean, you talk to one function that goes down, that just gets queued up, and once it's back up, that request gets executed by that new function.
So, and by the way, I mean the question is, and a basic question on functions, with it's for stateless workload. Yes, it is. But I'll let you as well talk about your perspective.
Yes, yes, but with durable functions, there are ways to have stateful workloads. So durable functions allow you to manage state, which really before that was only really doable in Service Fabric. And that's where you put your stateful applications into. But with durable functions, you can also run stateful. And then it's managed in storage accounts.
Yeah, but I have a question on the product, by the way. So I saw that you showed that you can do a auto remediation, and like how many vulnerabilities you can auto remediate. I mean, is there a list of vulnerabilities you have where you can auto remediate there?
Yeah. So we haven't published that list yet. But on Azure, we chose to remediate everything we can remediate without requiring user input. So there are certain things where, for example, we recommend you have VNet service endpoints on pretty much everything. But to actually configure that, to create the VNet service endpoint, we would have to ask you for input, like which VNet, which subnet, what's the name of your endpoint, etc., etc. Those we don't remediate. Those we will give you like pointers how to remediate it, and we point you to the documentation on Azure how to remediate it, but we don't yet, that's the emphasis. We will soon support that, but at this point in time, we only support remediation for things where we don't require input, like storage accounts should not allow default network access. Storage accounts should enforce HTTPS, secure traffic. Virtual machines should not have RDP or SSH open, or 5985, 5986. That was the whole oh my god vulnerability on the Linux agent. These sort of detections we can auto remediate. And it's
Perfect.
roughly in the 70% of our Azure detections that we can remediate.
Oh, nice. That's a interesting one. Like 70% is pretty high. In fact,
Yeah.
if you are
And we
getting all the 70%, one auto remediation is pretty high.
yeah, and we if you don't like what we remediated, then we also support rollback.
Wow.
So
Okay.
so when I say like, it can be so remediation in a lot of cases is a breaking change. We all know that. Yeah. You somebody probably thought about something and just made it work. Yeah, just make it work. And that means it's probably not that secure. If you now make it secure, you're probably going to break something in some cases. So if you really, really broke something and the business decides it's better to be up and insecure than down but secure, then just click the rollback button and it's all good again.
So there's one more question though in from the audience. Um, so he had some issue with his laptop, but he wants to know more of Log4j issue, and maybe you can talk about how customers are talking about the Log4j. You can repeat that for him.
Yeah, yeah. So we don't have any log4j issues. Hooray! We had a very nice weekend. We don't have any Java in our application. We don't have any Java dependencies in our application. But some of our customers actually told us that they used Argos um, to find and prioritize internet-facing applications or services in the environment, and then start fixing on and researching and assessing those services before they before they go and try to find something that they might not even know about. So they used Argos to find potential places where they might have log4j issues.
Okay, there were a couple of things. Uh, Again, there is a question on the detailed question on Log4j.
Hmm.
Um, so in a
Uh,
nutshell, yeah, I mean, you could just take that as a final comment on Log4j.
yeah, so we don't find log4j vulnerabilities in your environment, but we can, according to some of our customers, we can help you find resources that are publicly exposed to the internet. And from there, you can start then looking at these because they might be most vulnerable in your environment if they had the log4j issue.
Yes, thanks, Mithun. Thank you for letting us know that you enjoyed the session. Um, I mean, David, we can wait for a minute or two. If there are any questions from the audience, we can definitely take that. While we are waiting for questions to come in, uh, there is a survey link which is there on the screen. So you can take the survey link. There's an event ID. Just key in the event ID and uh, you know let us know how the session was for you, and we can bring more sessions like this.
Yeah,
Any questions from the audience? I'm just waiting for audience to post some of the questions as well. We can wait for 2 more minutes.
yeah.
While we are waiting, so David, you can definitely talk to me about
Yeah,
the
look,
Melbourne
maybe
cricket.
just to finish off, we do have a free trial, so you can use Argos for free for 30 days and just give it a go. We don't ask for a credit card. We're one of these nice people that don't have you put in your credit card. You can try it for free against your Azure subscription, and if you like it, get in touch with us. If you've come from the meetup here, from the session, the Reactor session, we will give you a bit of a discount on any subscription if you wanted to become a customer.
Let's give it a minute. Okay, so Mithun is talking about you should look into serverless tier of Cosmos DB. Uh, it's an yeah, it is, but then no multi-region deployment.
Yes,
That's something which you might be it might be an issue for you, right? Because you want to
correct.
have the data in all the places. Yeah.
Yes, we do need to deploy international or globally, really, eventually, and serverless. For we looked at it, and we did come up with some reasons why it also doesn't fit our requirements. Off the top of my head, I can't remember them now, but it wasn't just the multi-region.
There's one more question from Christina. Do you know whether WebSockets will work from front end through messaging to functions?
Right.
Chat apps.
Okay.
So basically, specifically from chat apps.
Yeah. Look, we use Signal R in our front end here. So yes, there's a WebSocket that is established here that talks to Signal R. Some of our functions will go and tell the front end via Signal R, via message. There's new data, and the website will automatically refresh. So it works.
Yes, Mithun. Thank you. I'm just posting it there.
Yeah. Yeah. So we haven't looked at WebPubSub yet, which is the new Signal R, but Signal R has been around for ages. It's super easy to configure and integrate into the application. So we just went with Signal R.
Perfect. I think. Thank you very much for your time, David.
No
Thanks for
worries.
coming
Thank
onto
you
the
very much.
show. Thank you for coming onto the show as well. And I'll let you go. You know, it's dinner time. Go back, have your dinner, sleep well. You have the security tool enabled, so you can sleep. You can go and sleep.
Exactly. Yeah, exactly. Thank you very much. That was great. Great audience, great questions. Thank you.
Thank you. Thank you, audience. Bye bye. See you.